Yes students, Jai Swaminarayan. Welcome to our video lecture. Having completed 4.1 and 4.2 students, today we are going to do some formal concepts of limit and then start one particular type of sum of limits. Now the first topic is working rules of limit. Our today's first topic, it is given on page number 150. We are going to have working rules of limit, and specifically one of the working rule can be asked in section B, students, VSQ. So I request all of you to pay attention and understand the basics. The first working rule is titled as addition, subtraction working rule. WR means working rule. I am writing in short. Now students, pay attention. Okay, before that, let me add one common, you can say, instruction. Then we'll start the first one. Sorry students, I forgot. Say fx and gx are any two functions and their limit as x tends to a. Let us for textbook are L and M respectively. So on page 150, these are given. Let fx and gx be any two real functions. Suppose that limit x tends to a, f of x is approaching a value L, and limit x tends to a, g of x is approaching a value n. Now let us give the first title, and that title is addition, subtraction working rule. The first working rule, students, is addition, subtraction working rule. Like this it is. Limit. Now I am writing L capital because I am in the habit of writing. There is no such rule. You can write L small also. Limit x tends to a, f of x plus g of x is equal to L plus L. Now how to read this, students? How to read this? Limit of addition of two functions is equal to addition of limit of both the functions. How to speak this in words? Limit of addition of two functions is equal to addition of limit of individual functions, and same way is true for your difference. Limit of difference of two functions is equal to difference of limit of both the functions. So this is how we speak in words. Second is multiplication working rule. Limit x tends to a, f of x into g of x is equal to L into, how to speak this in words? limit of product of two functions is equal to the product of limit of both the functions. Limit of product of two functions is equal to product of limit of individual functions. Third is division. Working rule. Limit of a rational function or limit of f of x upon g of x, specifically g of x not equal to 0, means the limit of this g of x not equal to 0 on the condition that n not equal to 0 is equal to the division of limit of individual functions. Limit of f of x upon g of x is equal to the division of limit of f and limit of g, provided limit of g is not equal to 0, because students, we cannot divide by 0. And the fourth working rule is working rule of a constant. Constant into function. Working rule. Say if we have limit x tends to a k into f of x, where k is a constant, then this limit is equal to k into a constant is always taken outside the limit. I will show you with the help of some students. So, the fourth working rule is the working rule of constant into function. A function is multiplied by a constant k, then k is taken outside, and limit x tends to f of x is nothing but l. So this are 1, 2, 3 and 4. Students, 4 basic working rules of limit. These are 4 basic working rules of limit. The first is addition subtraction working rule, second is multiplication, third is division, and fourth is constant into function working rule. I said this title is not given in textbook, but you can understand this as constant into function working rules. Now, the next is some standard forms of limit. The first is limit of a polynomial function. Now students, pay attention. All of you would be definitely allergic to the word polynomial. But do not worry students. What is a polynomial? I will explain. We have already done this before also. Suppose I have fx is equal to 2 plus x square plus x cube. This is the polynomial. A polynomial is an equation in x where all the terms of x will have power as integer. 3 is an integer, 2 is an integer, nothing means power 1, and here power is 0. 2 into x raised to 0 plus x raised to 1 plus x raised to 2 plus x raised to 3. So polynomial is nothing but a function in x where each term of x will have integral power. Say suppose if I write like this, p of x is equal to x raised to 1 by 2 minus 3x squared plus x cubed. This is not a polynomial because 1 by 2 is not an integer. So polynomial in the simplest form is an equation in terms of variable x or y or z, where every term will have power as integers. A general form of a polynomial function an x raised to n, where all the powers of x are integers and a0, a1, a2, a3, up to n are coefficients. a0 is a constant term. So, a polynomial is in the simplest form an equation in x where each and every term has power of x as integers. So, limit of a polynomial function, our next theory is the limit of a polynomial function. So, in the simplest term, limit of this function as x tends to 1, I will replace every x by 1. Limit of this function as x tends to 2, I will replace every x by 2. So, the limit of polynomial function as x tends to b will be nothing but replacing every x by b in this polynomial function. So, the answer will be a0 plus a1b plus a2b square plus a3b cube to a b raised to n. Why we need to write a? Because a is already there in the function. So, the limit of a polynomial function as x tends to a is simply replacing x by a. A is 2, then replace this x by 2. If a is 5, then replace this x by 5. If a is 1 by 2, replace this x by 1 by 2. So, students, polynomial means a function in variable x or y or z where every term of the variable has power as an integer. That is the main part. Positive integer, I should say. Power as an positive integer. So, this is what we have to understand in the limit of a polynomial function. So, a polynomial function is such a function where each term of x will have power as positive integer or minimum power 0, because in constant term the power of variable is 0. I should say specifically positive integer. So, need not worry. Now, students, don't get scared of a polynomial. A polynomial is an equation in variable where every term of variable will have power as positive integers. That's all. So, students, this was the basic theory which I was supposed to teach you today. 2 more formulas are there, but as and when we proceed with the sums, that time we will discuss. We have 2 more formulas of limit, but that should be discussed along with the sums. Now, today I am going to discuss some basic sums of limit which are based on factorization. Now, we don't have exercise 4.3 students, so please pay attention. Now, we are going to do some basic sums of limit, and those sums are, you can say, first 4 sums of section D. I am doing 2 sums at a time. So, all of you pay attention. Section D. Exercise 4. Sum number 1. Find limit x tends to 1. 3x squared minus 4x plus 1 upon x minus 1. And the second sum also I am writing. It is limit x tends to 3 x minus 3 divided by 2x squared minus 3x minus 9. Students, in today's sums, we do not have any formula. In today's sums, today's 4 sums, which I am going to do, students, we do not have any basic formula. Now, you substitute the limit in the numerator and denominator, we get 0. Check. x is 1, 1 square is 1. So 3 minus 4, minus 1 plus 1, 0, 1 minus 1, 0. So this type of sum are called 0 by 0 form. This we teach in science, but you can easily understand. So on substitution of limit, if your numerator and denominator becomes 0, at a time, this type of sums are called of which form? 0 by 0. Don't cancel 0 and 0 and write 1 as we like 2 by 2 is 1. Be careful. Now, so what we should do? What is making my denominator 0? This term. X minus 1, students, is making my denominator 0. And that is the problem. So we have to remove x minus 1. How to remove? The concept is your numerator term should be factorized to get x minus 1. Now n stands for numerator is equal to 3x square minus 4x plus 1. Now comes your 10th standard. Now comes your basics of 10th standard, which you have to apply. Factorize 3 into 1, which is 3. 3 into 1, which is 3, to get 4. Of course, minus 3 into minus 1 is minus 3. Plus 3. And minus 3 minus 1 is minus 4. So we have to factorize this. So we write this as 3x square minus 3x minus x plus 1. Now what is common from first two terms? 3x into bracket x minus 1 minus 1 common. So the factors are 3x minus 1 and x minus 1. We got x minus 1 as a common factor. We have x minus 1 as a common factor in the numerator as well as denominator. Yes or no? Of course, yes. So now the limit is limit x tends to 1, 3x minus 1 into x minus 1 upon x minus 1. You people are very eager to cancel. So now this changes to limit x tends to 1, 3x minus 1. Now in the tabular method I was reiterating x tends to 1 is never equal to 1. But now we always go for shortcuts. So while finding limit, we take x is equal to 1. So if I take here x is equal to 1, this will be 3 into 1 minus 1. So 3 minus 1, 2. Technically this will be never equal to 2. It will be nearer to 2. But as an approximation we directly write 2. So in the sums, whenever we take limit x tends to 1, finally we take here x is equal to 1. We do not go now by that table method. So this is a shortcut. Technically x is never equal to 1, so answer will be never equal to 2. But as an approximation we directly write it as 2. So again take here x is equal to 3, 3 minus 3 is 0. Take here 3 square 9 to the 18, 18 minus 9, 9 minus 9, 0. So this is of the type 0 by 0 form. So we have to factorize the quadratic term to get x minus 3 common. That is the main part of the sum. So here instead of factorizing numerator, I have to factorize denominator. So denominator d is equal to 2x square minus 3x minus 9. Now 2 into minus 9 will be minus 18. So factorize minus 18 to get minus 3. Minus 6 into 3 is also minus 18. Minus 6 plus 3 will be minus 3. So this is written as twice x square minus 6x plus 3x minus 9. what is common from first two terms? 2x, so x minus 3. 3 common, so x minus 3. So the factors are 2x plus 3 and x minus 3. Therefore, the limit x tends to 3 changes to x minus 3 upon x minus 3 into 2x plus 3. We are eager to cancel. Again, this is never technically equal to 3, but in the sum, we take it as 3. 3 to the 6 plus 1, 9. Mind you, this is 1. Pay attention. So here, division working rule comes into play. Limit of f by g is limit of f which is L upon m. So limit of a constant is always constant, students. Mark this as an important formula. You write it afterwards. Limit x tends to a. Only constant is there. Then the answer is only constant. So limit of 1 is 1. Here there is no x which is replaced by 3. So this is 1. And here 3 to the 6 plus 3, 9. So the answer is 1 by 9. Here the answer was 2. So remember, this limit of a constant is constant because there is no x which can be replaced by a. So students, limit of a constant is always constant. Now let us do sum number 3 and 4. So students, pay attention. Sum number 3 and 4. Fourth sum is limit x tends to minus 1. 3x square minus 2x minus 5 upon x plus 1. Okay, and writing the fifth sum also, it is limit x tends to 1. X square plus 2x minus 3 upon x square minus 1. Okay, students, now all of you please pay attention and concentrate. Now, take x is equal to minus 1. What is minus 1 square? 1. 1 into 3 is 3. Minus 1 into minus 2 is plus 2. 3 plus 2, 5. 5 minus 5, 0. Minus 1 plus 1, 0. So again, this is of the form 0 by 0. So we have to factorize and get rid of x plus 1 because x plus 1 is making denominator 0. Factorize numerator, which is 3x square minus 2x minus 5. 3 into minus 5 is minus 15 and minus 5 plus 3 is minus 2. We want minus 2x only. So we write this as 3x square plus 3x minus 5x minus 5. We can let any term first, don't worry, take x common. So what remains? 3x plus 1. Okay, students, here I would have taken, I should have taken 3x common, sorry. So what remains? X plus 1, take minus 5 common, sorry students, I should write here 3x, take minus 5 common, so x plus 1, so I get 3x minus 5 and x plus 1. So our limit is limit x tends to minus 1. 3x minus 5 into x plus 1 upon x plus 1 gets cancelled. Now by taking limit, I should directly replace x by minus 1. So this is 3 into minus 1 minus 5. So the answer is minus 8. So your basic concept of factorization, students, must be very, very here. Otherwise, you may face some problems. Take x as 1, 1 plus 2, 3 minus 3, 0, 1 minus 1, 0. So this is of the form 0 by 0. Let us factorize the numerator. X square plus 2x minus 3, nothing means 1. 1 into minus 3 is minus 3. And 3 minus 1 will be 2. So this is written as x square plus 3x minus x minus 3. Take x common, x plus 3, take minus 1 common. So the factors are x minus 1 and x plus 3. Here luckily denominator is also factorized. All of you know the factors of x square minus y square are x minus y into x plus y. So this is written as x minus 1 into x plus 1. Now our limit is limit x tends to 1, x minus 1 into x plus 3 upon x minus 1 into x plus 1, x minus 1 gets cancelled. Now apply division working rule. Limit of f upon g will be limit of f upon limit of g. This is called application of division working rule. Now take x as 1, 1 plus 3, 4, 1 plus 1, 2. So the final answer is 2. So this working rule are applied like this. Theories are bit different. Application is also different. So this is how students we have applied the basic rules, and once you understand this answer very, very easy, students, you should now try and do the remaining questions 5 and 6 on your own. If at all you can simplify. Don't worry, students, I am going to help you. We are not going to leave any single sum. So let us do one or two MCQs if we can. Many questions, students, we will do in the next lecture. Let us do, students, 1 or 2 MCQs. Now, section A, first 7 questions, first 6 questions we have done. Okay, let us do MCQ 7, 8, and 9. These are very, very easy, students. Section A, exercise 4. MCQ 7, limit x tends to 3, 3x minus 1. Simply replace x by 3, so this will be 3 into 3, 9 minus 1, so the answer is 8. So the correct option is D. MCQ 8, limit x tends to 4, square root of 4x plus 9, replace this x by 4, so square root of 4 into 4, 16 plus 9, which is 25, and root of 25 is 5. So the correct option is A. Now, MCQ 9, limit x tends to 10, just now I told, limit x tends to a of a constant is constant because there is no x to be replaced by a. There is no x to be replaced by 2, so the limit of a constant is constant. So your answer is 10. So the correct option is also A. So this is how students we basically apply the concepts of limit. So do the sums, write working rules twice, do the sums twice, once with looking and once without looking. In the next lecture, we will complete questions 5 to 11. Okay, thank you.